All right, if you're gearing up for your computer systems exam, you know just how much ground there is to cover. But what if I told you there was a kind of cheat sheet, not for the answers, obviously, but for the patterns, the logic behind the questions? Well, today, that's exactly what we're doing. We are cracking the code of the official examiner's report to figure out what really separates a good grade from a truly great one. So let's just start with the biggest question, the one that's probably on your mind right now. What is it that separates the top-performing students from everyone else? Is it really just about cramming more facts? Or is there some kind of strategy, something the best students are doing that you might be missing? Well, the best part is, we don't have to guess. The answers are right there, laid out for us in the official 2024 Examiner's Report. And let me tell you, this document is an absolute goldmine. It shows exactly where students nailed it and, way more importantly, where they stumbled. So let's dive in and start by looking at the two main paths students seem to take in this exam.
Yeah, the report paints this incredibly clear picture. It basically outlines two completely different routes students went down. One that leads straight to success, and the other, well, not so much.
And you can really see the difference here. It wasn't just about knowing more stuff. It was all about how that knowledge was put to use. The high scorers, they were actively applying what they knew to brand new situations, using super precise technical language, and had a deep understanding of core concepts like the fetch, decode, execute cycle. On the flip side, the weaker answers were often vague, they couldn't apply their knowledge, and they showed some really basic misunderstandings of key terms, especially when it came to databases. Okay, so let's get practical. Knowing the general vibe is one thing, but seeing the actual exam traps, that's where the real learning is. We're going to look at a couple of specific questions that really caught people out. First up, question 1A. This is bread and butter computer science, right? The fetch stage. It seems so simple, but a really fundamental mistake tripped up a ton of students right at the very beginning of the paper. And this quote from the report just nails the problem. The examiner said that students were describing registers as if they were alive, as if they were doing things, saying stuff like, the MAR fetches the address. The key thing to get is this: registers don't do anything. They're just passive storage spots. Think of them like a mailbox, not the mail carrier. They just hold stuff. They don't move it. That's the job of the buses. So let's walk through the correct sequence and really focus on what's doing the action. First, the address that's sitting in the program counter gets copied over to the MAR. See? The MAR isn't fetching, it's just receiving. Then, that address gets sent along the address bus. The control unit sends a read signal down the control bus, and only then does the data travel back along the data bus to get stored in the MDR. Finally, it gets copied to the CIR. See the difference? The buses are the movers, the registers are the holders. Getting that flow right is absolutely critical. Okay, let's jump to another classic pitfall, this time from question 7. Candidates got a scenario. A growing leisure center needs a database for 10,000 members. And the question was, should they use a flat file or a relational database? Again, seems simple enough, but it exposed a major gap in understanding for a lot of people. And there it is, straight from the horse's mouth. A huge number of students confused a database with a table. They were describing a relational database as being made of lots of related databases, not lots of related tables, and that's a fundamental error. So let's just clear this up once and for all. A table is just a single grid of data. That's it. A flat file database is a whole database that's made up of only one of those tables. And a relational database, well, that's a collection of multiple tables that are all linked together in some logical way. Getting that hierarchy straight in your head is just non-negotiable. Now, if there was one single topic that truly, and I mean truly, separated the top students from everyone else, the report makes it crystal clear what it was. It all came down to search engine indexing. This quote right here says it all. While a lot of students could talk about things like PageRank, very few could actually explain what search engine indexing even is. This was, without a doubt, the single biggest knowledge gap on the entire paper. So let's fix that right now. In the simplest terms, search engine indexing is just the process of building a gigantic database.
Little programs called bots or spiders or crawlers, they travel all over the web, following links from one page to the next. They analyze what's on those pages, and they build an index. Basically, a massive list of keywords that points to all the pages where those keywords appear. So when you search for something, you're not searching the live web in real time, you're just searching this huge pre-built index. It's way faster.
But hey, it wasn't all doom and gloom. It's just as important to look at where students did really, really well so we can see what a safe bet for grabbing marks looks like.
And the big winner here was question 4. Anything to do with number systems. We're talking binary, 2's complement, hexadecimal. All those conversions, they were handled extremely well by almost everyone.
In fact, the report specifically mentioned how great it was to see so many people scoring full marks on this section. And what that tells you is that with some focused, technical practice, these marks are absolutely there for the taking. This is a topic that you can and you absolutely should master.
So, what's the big takeaway here? What does all this mean for you? We've decoded the traps, we've celebrated the wins, now let's put it all together into a solid, actionable blueprint for your own success.
Okay, here's your final checklist. First, master the core definitions. Seriously, know the difference between a register and a bus, a table and a database. Second, don't just memorize things, learn to apply what you know to brand new problems. Third, use precise technical language, don't be vague. And finally, dig deep into those more complex topics like search engine indexing because that is where the top marks are won or lost.
Look, the patterns for success, they're not a secret. They are laid out for you right here in the examiner's own words. We've shown you the code, so the only question left is, are you ready to crack it?